3D printer is made by with the electrobeam melting method. You can melt slices of titanium powder. That is slice by slice. You can build in such a way any geometry. So with this technology we have developed a lot of structure, very porous structure, to rebuild and to regenerate bone.
Okay.
Our knowledge is based on regeneration of big defects of bones. We made several tests with animals with high porous structure, porous up to 90%. Part of the volume, the 90%, is vascularized. Vessels go inside and then start to grow up and to rebuild your bone, your own bone. The big advantage is that there is, with this technology and with this new philosophy of design and manufacture implants for bone replacement, is that you should use only one implant one time. I mean, you don't need to replace implants.
So it's forever.
Actually, yes. You put and then the final result is a mix between your new bone reconstruction and a scaffold that is your implant. So when it's everybody together, then can stay there because it's your own bone. 90% of this volume is your own bone. Another very important application. In the chest, the needs are different than in normal bones, in the loading bone. In the chest, what you need is to have the possibility to expand,
to be flexible, right?
And flexible. So it's not important to regenerate, but to follow the respiration movements during brace. So this is a patent. This structure are patented by us. This is one implant for a case that we are doing in Germany, and it's a reconstruction on the second, third, fourth ribs, and it's you can see that it's totally elastic and it's fixed. This is reconstruction for big tumors. This was a basocellular tumor that was in a big area. This structure is our structure, and we were the first in the world to develop elastic implants to follow the braiding movement. We make one implant, one patient. This is for one patient. We receive the tomography, the computer tomography. We rebuild the model in 3D. And we can work on the CAD, in the computerized design, and then we work designing directly on the reconstruction of the tomography. It's working, not only working, I mean, the patients can restart breathing without any problem of respiration. Normally, what is in the market now is rigid. So you can reconstruct. There is one part of the needs of the reconstruction that is good. That is the protection part. If it's rigid, it works. But then you can lose up to 20% of the capacity of the volume of the respiration volume. Patients that were treated with the normal rigid implants, normally after the reconstruction, they can breathe not in a physiological way. They lose capacity, so if they climb stairs or if they have to make some activity sports, they can't breathe so well as a patient that you can restore the total physiological capacity of the lungs. This is a custom made in Germany that will implant in a patient in the next 20 days.
Wow. And where?
And in Germany. In an hospital of the middle Germany. As part we need to rebuild bone. So this is like it looks reconstruction for bone regeneration. It's porous inside, and there is a shell that is with the same pore in the direction of the inside network. The clavicle is a challenger. Still a challenger because it's a joint that it works in an opposite direction. Normal joint works in compression. The concave part in contact with the convex one with the compression, it will fit always, and it works. But clavicle works in distraction. The part that can join in the normal working of a clavicle are soft tissue around that prevent luxation. We are mimicking the same principle than nature. I mean, we have an artificial ligament that works like surrounding soft tissue and avoid that the joint can be luxated. Nice implant that is for Bilbao. It's a girl, is 10 years old. There is an osteosarcoma that is a very aggressive tumor, and the actual situation is like this, that this is the patient. I mean, this is the tumor. The bone grew up from the cartilage that are open in the extremity. You can remove this part of the tumor without any security margin because there is cartilage. Normally in osteosarcoma, in the other part, for example, you need 3 centimeters of margin to be sure that there is no infiltration of a tumor. This part will be cut by a cutting guide. This kind of implant, the idea is that can grow up.
Oh, because
and
she
then
is just
of
10
course
years
because
old,
10
so
years old, so we are destroying the margin where she will grow up, so this leg will not grow up anymore. So what we can do is to leave an open door for the next steps. If she will grow up, then they will follow, and then we'll lock it in another position, and sometimes she will have a couple of surgery more till it stops to grow up, and then it can survive with the implant.
Will she be able to walk and also
Of
maybe
course,
run and jump and everything what we used to do?
You can be able to make a normal life. Sometimes, of course, not to make aggressive sports or very big performances, physical performances.
But for normal, right?
But you can run a bit, and probably you could play tennis slowly and a normal life. We are rebuilding all the proximal part, is another tumor, and we will use vascularized bone graft from the same patient. Then the idea is to rebuild the part with part of the fibula. This is the fibula. This is like a natural stock or bone stock that you can use for any reconstruction that you need. And you can take vessels, you can join the vessels in the place where you need to rebuild. It's the way in which, for example, you can rebuild mandibular joint and part of for tumors or extremity in young patients. Otherwise, the chance is to put porous titanium and wait that this will be filled by your bone also. Diamonds on the beach on a girl that won't get old. Another case, also the Hospital de Cruces de Bilbao. This is a perone that has been cut and rounded 180 degrees. Some parts, 80% of the load will be at the beginning supported by the implants, and around 20% to the bone, so the bone start to be bigger and bigger, because if it works, it needs to grow up. You can survive with this implant all the life long, because the implant will break always. It can survive 10 years, 15 years, but fatigue behavior will be any year worse and worse, and it breaks about always. Artificial materials as a deadline. The future is to regenerate.
Ez micsoda?
Hát ez a taraszobor, tudod, a termékenység szobor.
Ja, a termékenység. És ezzel mit kell csinálni? Rá kell ülni, vagy
Nem, berakod a szobádba és megvárod, hogy jöjjön a gyerek.
hogy hasson?
This is the same material that we use for the implants. I mean, it's titanium 6 aluminium for vanadium that is manufactured by 3D printer. So this is a good way to show to the surgeons how much is it resistant, this material, and how light it is. 30 grams of materials, and it's elastic, it can jump, and can survive under loading without any problems. If you make porous, you can use just what you need. So if you use more, you make more resistant, it's not an advantage. The opposite, I mean, you need elasticity and empty space if you want to regenerate. If the implant is stronger and not porous, then this space is lost forever.
Okay.
So what we do is just to use the minimum to support the time that needs the bone to rebuild. This is a reconstruction with fibula. It was a total replacement of the jaw.
So
This is from the fibula.
okay, but isn't it
This
missing from the fibula what you take away from there?
No, the fibula has some vessels that go from around the bone. They remove very few soft tissue. Inside the soft tissue there is the vessels, and then you cut the bone, you fix the bone, but the vessels they reconnect in the neck to the big artery and vein that are there. These are pieces of other patients, just to have an idea
Wow.
how flexible it is.
Na most tudom hajtogatni.
The origins, when we demonstrated it's possible to rebuild your own bone, it was made on sheep in 2011. After that, we make histology of the part that we rebuilt, and you can see that is your own bone, and it's full integrated on the implant. So what you have is this volume that is still 10% metal and the rest is all bone. If it breaks inside because you fall and you have an accident, then you can treat like your own bone. There is another case, it was a tumor in a scapula. We tried to save just a few parts, 3 centimeters of the medial part of the scapula, and then we designed and manufactured an implant to rebuild the joint, and was a partial joint. And this is a video of the patient after 6 months after the surgery. This is really a very unexpected good results. Even them were surprised, because it was first time, and also for us was the first time. No? The arm affected was the left part, but it's not possible to recognize from the movement.
Beszélhetsz a